Okay, welcome back. This is the third lesson recording for week 5 of IM1. So far, I've left you with practice problem x, absolute value of x is equal to 3, and hopefully you got the answer to be x can be 3 or x can be negative 3. I'm going to show you a notation that you're going to find while you're doing your homework. Okay, so when you see this curly bracket, what does that mean? That means this implies that x can be 3, and this is implied that x is equal to negative 3, and there is a or. So it's what we call solution set. So any solution to the equation, we put it inside the curly parenthesis or curly bracket. And notice this is very different to 3 comma negative 3 in parentheses. When you have this notation, this is coordinate notation, right? This is talking about coordinate. Okay, while as this is talking about solution set. So you are going to come across this, and you will come across this in your future IM2 and so on. So make sure you understand. Okay, second problem that I left you with was absolute value of x is equal to negative 2. Let's think about this. When you apply the absolute value function of x to, can the machine ever pop out a negative number? No, it's not possible, is it? So x cannot be anything for this to be true. So we say this is no solution. Okay, so that was a trick question. All right, so then let's extend this a little bit more and try to solve some more difficult problems. So I have another example. Solve for x. Absolute value of x minus 5 is equal to 9. So here we go. Let's see if we can move this up. Okay, so I'm going to go through this first. So considering that the value inside, once you apply the absolute value and comes out 9, that means the value inside here could be positive value or of 9 or negative value of 9, right? I hope you're starting to see this. So this inside could be positive, could be positive 9 or negative 9, right? So that means this inside was x minus 5 could be positive 9, or x minus 5 was negative 9. So we have two different equations from the one equation, one absolute value equation. Okay, and then from here, it's pretty simple. You know how to solve this. We add 5 to both sides, and that leaves us with x is equal to what? 9 plus 5 is 14. And what about on this side? Add 5 to both sides again, and you are left with x is, in this case, x is equal to negative 4. Okay, so my solution set would look like this: negative 4, comma 14. Does it really matter which order I put in? No, generally not. But I prefer to put in the negative number first, just so that I know, but it does not really matter that much. I'm not going to mark you wrong if you do not. Okay, so what do? We made sure that from one absolute value function equation that came out to two different equations, and then solve for each of those equations. Okay, now it's important that we check our answers, because sometimes, and you will see later on, that it does not, all the solutions we say is true does not always work. So we need to plug this back in to the original equation. So we need to check. So check. So let's start with negative 4. X is negative 4. And if we go back to absolute value function of negative 4, we plug it back. Instead of writing x, we plug it back into negative 4 minus 5 is equal to 9. Is that true? What's negative 5 minus negative 4 minus negative 5? Minus 5 is negative 9. and then you take the absolute value of that. What's negative 9 absolute value of? That's going to be 9 is equal to 9, so that checks out. Okay, what about the other solution? X is 14. Let's plug it back to that original equation. So that's going to be 14 minus 5 is absolute value of 14 minus 5. Is that equal to 9? Well, 14 minus 5 is 9. And taking an absolute value of 9 is still just 9. And 9 is equal to 9. So it checks out. Okay, so to summarize what we did, I am going to write the steps that, oops, I can't really see. I'm sorry. So that's what I have. So the steps that we did. Okay, so when you have steps that were involved, this number 1 is to say isolate the absolute value expression. So isolate the absolute value expression. Well, this step probably won't mean that much to you yet, because this problem was already, the absolute value function was already isolated. What does isolate mean? It means, what it means is to set it means just the absolute value function expression on one side of the equal sign. Okay, so we just want the absolute value function expression on that one side of the equal sign. We don't want anything else around it, followed by a number on the other side. That's what it means. And then what is the second step? Is to rewrite the equation, okay, to get rid of the absolute value function sign. Okay, so then this is where you write two equations from the original equation without the absolute value sign. Okay, so how do we do that? We set the expression inside the absolute value sign to equal to the negative of the constant, or that number on one side, and the other equation equal to the negative value of the constant c. Okay, so we are going to set expression inside the part absolute value sign to be equal to the negative of c value. That's the constant. That's like, for example, the 9 was a c value. Okay, so we put 1 to be negative, so that's what we did with this equation, and the other one, and the other equation equal to the positive c value. Okay, so that's what we did here. We set the expression, what's inside here, we wrote that inside without the absolute value function, and then we set it to be positive. And the second equation was, we set what's inside the absolute value function, set it to be negative. Okay, and then third, we all know what to do, because we are a pro at this by now. We just solve for x. And then finally check your answers or solutions by plugging it back to original equation. Okay, to the original problem. Okay, all right, so I am going to leave you with a actually I'm just going to move on because I think, well, let's actually give you a practice problem. Okay, I want you to try to solve this time. This is a little bit different problem. What if you are given 3x is equal to 6? Okay, how would you do this? This is still the same thing. It's a one-step equation, but instead of subtracting, now the expression is 3x. That means 3 times x. Okay, it's the same principle. Same principle. So please try this now, and I am going to show you the answers. Okay, so I hope you tried this problem. Here is my solution. So you first use whatever the expression is and set it to be positive and negative of the expression. So you have two equations, and then from here you solve. You divide both sides by 3 and you get x is equal to 2, and divide by both sides by 3 and x is negative 2, and you get the solution to be 2 comma negative 2 in the solution set. Again, then I have to check my answers to make sure it is correct, and they do work out to be correct. Great. So then I am going to give another example. Now the equation is getting a little bit more complicated, but it's the same principle. So from here, the absolute value function is already isolated because you only have absolute value expression on one side of the equal sign. So I just need to create two equations. The first being negative 6x plus 5. The part that is inside the absolute value function can be positive or it can be negative. And then from here, I am just going to solve. What do I do next? I subtract 5 from both sides, and that leaves me with negative 6x is equal to 3. So then I divide both sides by negative 6 and get x is 3 divided by negative 6. What's 3? Can I simplify this anymore? Well, I can also divide both numerator and denominator by 3. So that becomes 1 over 2. And don't forget the negative sign, so it's negative half. What about this side? I am going to subtract 5 from both sides, and that leaves me with negative 6x is equal to negative 13 this time. And then from here, I am going to divide both sides by negative 6. And so this leaves me with x is 13 divided by 6. And negative divided by negative is going to be positive. Okay, so my solution set is half, negative half, comma, 13 over 6. Yes, it's a fraction, but we don't have to be afraid of fractions. Now we have to check to make sure that it is correct. And so substituting back in, so negative 6 times negative half plus 5 is equal to 8. And that's the question. Is that true? What's negative 6 times negative 1? That's going to be positive 6 divided by, so we have 6 divided by 2 plus 5. 6 divided by 2 is 3 plus 5. And that is absolute value of 8 is 8. So 8 is equal to 8. That checks out. Alright, the other equation is absolute value of negative 6 times 13 over 6 plus 5, which is equal to 8. And the question is it true? Negative 6 times 13 divided by 6. 6 and 6 cancels out, and you are left with negative 13 plus 5 here is equal to 8. Negative 13 plus 5 is 8. And absolute value of 8 is, again, 8 is equal to 8. So they check out. I am going to leave you with a practice problem for you to do. And that is going to be absolute value of 2x minus 5 is equal to 7. Please pause the video. Well, actually, the answer will be continued in the next video.